How y'all doing, motherfuckers? I'm sorry, I don't, I don't know what came over me. Um, Please forgive me for those that are still here. This is episode 6, maybe 5, 6 of the adventure game programming series. It's a short series. We're probably more than halfway finished. Where we left off last time, we had links between the game, and we also had links between scenes in the game, and we had narration text. Since last time, I've changed some of the text around in the game so that it's a little funnier, or just um, is better than what I had before. So every scene now has a narrative that types out like I wanted to. So that's basically where we are. Right now, what I want to do is I want to add some kind of branching to the game. Now, I already have branching paths, but what I would like to do is have branching based off of what items you might have in your inventory. So what I'm thinking of doing here is first, here you're supposed to see a key. So we need to implement that before we do anything else. And then we need to implement the ability to take the key into our inventory. And then we need to implement branching conditionals or directives in our Scn files so that we can make different directives happen based off of different items. And that might be enough to get us started in our game and really take care of most of the logic that's going to be in this simple example. So first and foremost, if I were to go into my assets, you would see that I have scene 4, but then I have this perfectly overlaid key, which I rendered out as a separate layer in Blender, so that if I were to draw this key on top of scene 4, it would fit perfectly. Now, I could just load in scene 4, which is 1280 by 720, and just draw that on top of scene 4 and everything would work. But I think that's kind of really dumb, because suppose this game was going to be a full-fledged game and we had tons of items. Wasting entire images for items that don't take up the entire screen is really stupid. So what I'd like to do is crop out scene 4 obj1 into a smaller image and make note of where it would be placed so that we could be efficient with both our on-disk usage and in-RAM usage of the textures. So that's what we're going to do. So I'm loading up GIMP right now, and I'm going to throw in scene 4 obj. And what I'm going to do is I'm just going to quickly crop this, but make note of the crop region so that we could essentially use that to bring it back. Now, really, the only thing I care about at this point is going to be the position, and that's 250, or what is that, 264, 293. And now I could take this, and I could save it out as the cropped version of itself, and it'll take up a lot less space on the disk and even less space in RAM when the game's loading. So that's much better. So now we know that we have an item, and we know that we have the position of the item. So I'm going to get out of GIMP. And this is something we would do for every item in the game. So assume I had a bunch of either items, like a gun or something, which I might add later if I have time. So now we have our key object, and what we'd like to do is overlay it as an object into our game. So like I've done before, I'm going to start out with tentatively how the Scn file might look, and then we will program it and we'll go from there. So what I'm thinking of doing is just basically having a directive called item, which we have. The first argument to that might just be the number of the item, which will correspond to this obj1 in the file, and then the x and y position of where the item should appear on the screen, and that should be enough. Maybe I should give it a name. That would be kind of smart, right? So I'll just do like key. And this will only be used if I decide to like have an inventory menu, which I probably won't need to program, simply because I'm going to have this kind of follow a more simple thing where items work automatically and you don't need to select them. So that's what we're going to have for this. So that's what it looks like in the Scn file. Let's go ahead and code it out as a class. So I'm going to go ahead and create a class here called item. It's going to be quite simple. It's going to follow, I guess I don't have any other examples, but it's going to look like this. It's going to have a couple fields. The simplest is going to be XY position. I'm going to use int for these. going to call this index, which is basically going to correspond to this item ID here. And then we're going to have a string. And the string is going to be the name or the description, one of the both. So the idea with item is we're going to construct it with all these things as arguments. We're going to go ahead and bring these in. So there's our items sort of ready. I'd like to go ahead and get ready to construct the items from the Scn file. Now I'm going to try to realize or figure out where they should live. There's going to be an array of items, and those are going to be the items that the user has in the current game. They can't live in the scene because scenes get loaded and unloaded as you go through, so the best place for them would actually be the game loop. So that's probably where I'm going to go ahead and do this. So I need to go ahead and get vector included into the game loop header. And what I'm going to go ahead and do here, so we got a vector array of items here. We should have shared pointers to items because I do not want to allocate these as value types. So that should get us our items array, and that's basically going to be the array of items that have been obtained throughout the game as we go through. This is going to be a little bit tricky because there's not just going to be an array of obtained items or items that the user has. There's also going to be an array of items that can be obtained or that are in the scene. So we're actually going to have an items array in scene as well. And like I said, the difference between those is which ones are available to be grabbed versus which ones have been grabbed. And we're going to allow myself to essentially, when I process and when I mouse press, to add to the items based off of whether or not an item has been clicked on. So why don't I really quickly create a method in the game loop called add item that takes a smart pointer to an item and adds that item into the items array in the game loop. So that'll be pretty simple to implement. The way that's going to look. This is just a way for me to pass items from the scene into the game loop, which means that they are in the user's inventory. I could rename this inventory if I'd like, just to make it a little easier for people reading the code to distinguish. And at this point, I can just say inventory pushback item, and then that adds the item to the inventory, which is awesome. This thing's complaining. Fuck this thing. Item.h. All right. So far, so good. So now, to recap, we have an items array per scene and an inventory array per game. And the items array is going to be populated when we parse the Scn file. So we're finally ready to start doing that. Let me go ahead and pull up scene and go to the code that parses the Scn so that we can get that part going. So I'm just going to go ahead and add a handler here for the directive item. And I'm going to double check how this is going to look. So the first thing we're going to have is we're going to have the identifier. What did I call that? Wouldn't hurt to have item.h open here. Index is what I called that. X, Y, so we'll read all those in. Right? We're going to start, kind of follow the same pattern we had before, where we're going to start one of these out as -1. And then if we could not read it, a 0 index would be invalid here for items, but I'm going to go ahead and just leave this check as a, well, no, let's make it. So basically, if we could not read the index, then we throw an error and we break. Now at this point, we've read index X and Y, but we need to do another string quoting point based, or quote-based string parse here, much like we did with the narrative. Now, this is some fun opportunity for me to teach you guys some decent C++11 software engineering practices or code reusage. We already have code that parses in text perfectly right here, and it would be very dumb for me to duplicate this code, but at the same time, I'm not all that thrilled about exploding this out into a public method here into scene because that's kind of unruly. and really only need this method inside this function. So this is an opportunity for us to use a local function, or better named in C++11, a Lambda function, so that I can define the local function inside our loadScene method and call it multiple times. So check this out. This is really cool. I'm going to cut this out of here. I'm going to create a local function right here, right after the file's been created, but before we go into the actual parsing code. And I'm going to call this parse quotes, and this is basically going to be equal to, this is the syntax for a Lambda function, something that takes right now I'm just going to have no arguments, and let me think what this would look like. I don't even know if I'll need any arguments, because INF can be captured here by reference, so we put that into the capture list so that it basically can be available from the outer variable can be available in the inner function. I would like it to return the actual text. So what I'm thinking of doing it is actually having it return text. And then the error would basically be something you would pass in by reference like this. This is how you handle the multiple return value case. So I could do this, right? There's no break out of here because we're not inside a loop anymore, but that's easy to handle. We just basically set error to true, and then I'll break if this function returns improperly. And we don't need to worry about narrative being equal to text because we're going to do that as well. So this is basically a function that would parse quotes for us based off of the current state of the stream, and then return the text if it was parsed correctly and set error to true if it wasn't, and error gets passed by reference. So check out how we would use this. So this is what we originally had at code and narrative. What I'm going to do is I'm basically going to say string text equals parse quotes, pass our error bool in by reference, and if there was not an error, set the narrative equal to the text. Otherwise, break. And that's all we need to do. And what's really cool is now here I can reuse that exact same paradigm or pattern when I want to parse the quotes from item, except this time I want to have not the narrative equal to it, but basically we're going to reuse that for the item itself. So this will be pretty simple. We basically do index. We're going to add this little check here. So this is the part where we're absolutely sure that we can use the item. Otherwise, we need to break out of the parsing loop. So this at this point we basically have everything we need to. I like to keep these together to create our item. So at this point we basically can create auto item via C++11 make shared and pass in everything we have: index, x, y, and text. This should compile. Oh, that was stupid. I mistyped this. This should be capital. It does. And at this point, we can push it into the items array because it's been properly parsed. That is awesome. I'd like to test this because I don't like to move ahead if I'm not sure that code that I worked was working. So the easiest way for me to do this would be just call get name on the item that we just parsed, and we should see it pop out in the loop or in the console output while we're running our game once we go into scene 4. So that's what I'm going to do. I'm going to go to scene 4, and we have key right there. Item was parsed correctly, and we have an item in the array. So all we have to do now is render the bloody thing, which is pretty simple to do. Basically, when it comes time to render the scene, we iterate over all items. Like so. And this should render the item on top of the background image, and if for any reason the text box was going to cover up the item, the text box will be on top of the item. So that's the order we're going to use for rendering this. Again, I like to use reference parameters when I iterate through arrays in C++11 using this colon notation. And the reason why I like to do that is because if you don't, it will create a value copy of every item every time it goes through the array. And in the case of C++11 smart pointers, that will inefficiently and unnecessarily increment and decrement the reference count, which is just inefficient and slow. So that's why I use this ampersand. Okay, so now we have the item. render function called. If you guys remember, I haven't implemented that yet, so if I were to run this, nothing would happen. But it's pretty easy for me to just go ahead and render the texture, if the texture existed, which it doesn't. But again, I'm going to do things a little bit out of order to not interrupt my train of thought here. And it's pretty simple. We ask it to go for a full copy from this. So render the entire image, and the destination rect is basically going to be set equal to the X and Y position, and then the width and height of the image that came in, which we don't have, and we're going to need to create fields for that. So upon initialization, we need to do a couple things. We need width and height, and we need that to exist inside an STL surface. We need to obtain that from an STL surface. We use the same old image load to load the file name, and we're going to build out the file name based off of the scene, which, god damn it, we don't have the name of, and then the object. So I know we're going to need a string stream. I know we're going to need to use the standard namespace. We know this is going to look something like scene. Let's put a placeholder in here for now. Got to figure out how I'm going to get that into here. I like to keep myself consistent if I can help it. Scene ID underscore obj index and then dot ping. At that point, we can get the C++ string out of the stream, convert that to a C string, then we can load in the surface. Once we know the surface is good, we then obtain the width and the height, which we're going to need down below when we render it. And then we are going to obtain the texture. We just got a whole bunch of arguments that needed to be passed to item. We need the renderer. We need the scene ID. So we need those for every item that gets created. That covers us there. Here comes the renderer. Surface is there. That just created our texture. Scene ID no longer needs to be a temporary. Now, once we are done, we can free the surface that was used to create the texture. We're going to need to free the texture when the item goes down, so let's get ready to take care of that with a constructor. Don't want to forget to do that. Just checking to see if I did most of this stuff correct. The renderer, the scene ID gets passed in. We have the scene ID now. We can build this out. We got everything we need to create the file name. We got the X, Y, width, and height. Item looks good. We're going to need to modify our constructor calls to item from the scene so we can pass it in the necessary information. Okay. Renderer, and then scene ID. So at this point, we know that item needs to know the scene ID, and I don't store that anywhere. So what I'm thinking of doing is I already know what the image is. It's pretty well assumed that image will be placed in the Scn files before item is placed. So what I'm going to do is just reuse that parsed image variable that was parsed up here, and that should be sufficient to pass that to the item so the item can find out which scene ID that we're within. I'm going to go ahead and run this and see what happens, and see if I have any luck with this just kind of working. It looks like it worked. It looks really well. I'm not sure, 100% sure if it's crossfading the way I would like it to. So maybe I will add a crossfade for the key. So in order to make the item properly fade with the scene, I need to add an argument to render for just opacity. And essentially, if that opacity comes in less than 1, I need to honor that using the same method that I used to render the scene background semi-transparent. So basically here comes opacity and is a forwarded argument from the scene, and I gotta redo the same jazz that I did before, but essentially I have to do it for this image instead of the scene background image. So just gonna go ahead and set this to none back, and let's go ahead and see what that looks like. There we go. That looks much better. And we have a key. And you'll notice, again, this is pretty cool because we're doing compositing here. The original image was separate, and it looks as if they're one image. But the reason why I do this is once I pick up the key, I can take it away, and it'll, everything will kind of come into place. So we need to go ahead and implement that. What I'd like to do is have a special mouse cursor, which I've already got in the game for when we hover over a possible item. I'm going to turn the mouse cursor blue. And then if you click, I'm going to take the item away and add it into your inventory. So let me go ahead and take care of the first part of that, which is the mouse cursor. I'm just looking for where I do that. I believe it's in process. So first I check all the links, and I guess I'll give those precedence. It really doesn't matter. I don't intend on overlapping these kind of things. So maybe I'll give the items precedence. So for auto item in all items. I'd like to have the item be the function that tells me whether or not I am inside of its bounds, because it has access to the width and height inside of it. So this is pretty simple. I basically just say point inside. I pass in the mouse cursor position, and then this thing returns a boolean of whether or not that point is inside the rectangle of the item. So we basically do a very similar if statement to what we had before inside scene, which is this thing. We basically return this expression straight up as a boolean. Now the link.region.stuff is not necessary, so I'm just going to kind of get rid of that. This should be sufficient to work. And then here what I do is I basically say if item point inside the mouse cursor position. We set the cursor for the game loop. To cursor item. We set inside any to true so we don't end up accidentally setting it back. And this should be enough for us to get the cursor that we need when we hover over the thing. Unless I made a mistake. See how it turns blue? And it only turns blue when we're hovering over the item, which is exactly what I want. That's good. Okay, so at this point, you could probably follow along with how this would work. We're going to follow the exact same idea. But when we click the mouse, we're going to take the thing away and we're going to bring it into the inventory. So at this point, when we've clicked down on the mouse, instead of changing the mouse cursor, we're going to do game loop. We're going to add item, the item itself. And then we're going to remove the item from the items array. So I didn't mean to take you guys through this. This is going to be really brutal. I'm sorry. But this simple thing that we need to do here actually exposes a major rookie mistake that people can make when they're doing range-based for loops, which is what this is in C++11. I didn't want to get into it, but I'd be doing you a disservice if I didn't explain how to handle this problem. So here's what the problem is. We need to remove item from the items array once we add it to the game inventory. And the reason why is once you click the item, we need to make it appear to disappear from the scene so that it's as if you grabbed it and it's not rendered anymore and you can't grab it twice and so forth. The problem is you cannot remove something from a for loop container while you are iterating through it. If you do that, you break the internal consistency of the iterators that are iterating through it. There are multiple ways to handle that. None of them are straightforward. The way that I like to do it is I like to have an object up here that is the placeholder for the object I intend to remove, and I need to store. I usually will store that up here, set it to null or nothing, and then afterwards, if I've decided to remove something, I remove it after the for loop. What that thing is it's called an iterator. I think I went into these at least in some detail when I went through the C++11 series on data structures, that particular video in that series. I'll declare one and kind of show you what it looks like, and then I'll show you how we need to use that to remove. Because you cannot remove from a C++11 or a C++ vector array without an iterator. You can't remove by value. So I can't pass it the shared pointer called item and ask it to remove that. I have to pass it the iterator. So here's what the iterator looks like. It's the array itself. So remember, this is a vector of shared pointer of items, right? So it's pretty ugly looking. And then it's that thing, iterator, and that's what IT looks like. Now, no one would, in their right mind, would want to type that out. So typically what I would do is I would just do auto and set that equal to items.end, which basically is kind of like the null iterator. It's off the end of the items. And that tells me that that is basically the same exact type that we would have had to type out, but I'm using type inference so that IT is that type automatically through auto. Sorry, guys. At that point, I want to give it a better name, so I'm going to call it item2remove, right? Now, this range-based for loop just doesn't make sense anymore because I don't have access to the iterator. So instead, what I'm going to do is I'm going to do auto item iter equals items begin, which is the first iterator. I make sure that it does not go off the end, so I do item iter not equal items.end, and then I do item iter plus plus. This is the old-fashioned way to iterate through a C++ data structure, or a templatized STL C++ data structure. So this is how we can have the access to the iterator every single time through the loop. Then what I do is I just do auto item equals star item iterator, which dereferences it. This is how you get access to the item that the iterator is pointing to. And then finally, if we decide we need to remove it, I set item to remove equal to the item iterator. And finally, if item to remove indeed has been set, which means it's not equal to items end, I'm so sorry, guys. I call items.erase. See, it needs the iterator as the argument. Item to remove. This is pretty valuable. Not a lot of people that deal with C++ like to do stuff like this, or it's very difficult when they're learning, but this is how you deal with this specific problem. There are other ways to do it, but this is probably, unfortunately, the simplest way. I could show you guys without introducing even more concepts. There are a few other ways I could do this, but this is the way. So that is the damn way to grab an item and add it to the inventory. The important parts to take away from this are, if the mouse was inside, when we click down, we add it to the game loop item inventory, and then we take it out of the scene items array. Let's run this and see how this looks. So we go through this, we go through this, we go through this. It says there's a key on the ground. Perhaps it has some purpose. If I click it, indeed, we have the key. The key is now permanently in our inventory. That's going to be it. This video ran way too long. I'm going to split the next part into a separate episode when we're going to cover how to conditionally change the logic and run different conditionals based off of, or different directives in our scene files based off of whether or not you have an item in the inventory or not. So that's where we're going to go next time. That's the end of this episode, guys. Thanks for watching. I wanted to make music for this game, at least one song. Really just one song that was going to kind of play, kind of like with an 8-bit feel over top of this game. And I quickly realized when I opened up my 8-bit tracker software that I am not a music composer. So any of the viewers out there, if you want to make a song for this game, just send it to me kind of as like a free gift to the channel. I'll include it in the tutorial series. So that would be cool. If not, no big deal. There just won't be any music this game. I've programmed music in the past in my other series, so it's not that different from what you've already seen. But it's kind of, I would like to have some in the game. That would be kind of cool. So if you guys, if anybody out there wants to make a music track that fits with the mood of this game, go ahead and send it to me. That would be pretty sweet. So you maybe like send me a SoundCloud link or something. So, all right.